Hi everyone, welcome to AI Crack channel. This is Akash Gangwar and today we'll be studying Progressionist Lecture 3. So in this lecture we'll be talking about properties of GP and also we'll be talking about a GP. So let's start with an example. If in a GP of 3 n terms, S1 denotes the sum of first n terms, S2 denotes the sum of second block of n terms and S3 denotes the sum of last n terms, then S1, S2 and S3 are in. So let's try to write individual S1, S2 and S3. So we have the GP, let's say AR square, and the nth term would be AR n minus 1, n plus 1th term would be ARn plus 1, then 2nth term would be AR 2n minus 1, and similarly 2n plus 1th term would be AR 2n plus 1 till 3nth term would be AR 3n minus 1. Now this portion is S1, this portion is S2, and this portion is S3. So let's find out the S1 value. The summation of this first series is S1. So let's try to find out the S1 value. So in this case, the first term is A, common difference is R. So we'll use the basic formula. A times 1 minus common difference raised to power the number of elements divided by 1 minus R. Similarly, S2 would be, here the first term is A R raised to power N. Common difference is again R only, and the number of terms is N divided by 1 minus R. Similarly, S3 would be AR 2N, because the first term over here is AR is per 2N, multiplied by 1 minus R is per N divided by 1 minus R. Now you can see that this term is common in every summation S1, S2, S3. So this is, let's say this is K. So this is AK, this is AR, sorry, this is, yes, this is N. It looked like 4. AR N times K, and this is AR 2N times K. Okay. Now you can clearly see that the common difference over here is R is per N. This one, this one, this one. The rest, the remaining terms are common, and basically the factor is common. AK is a factor which is common in every term, and Rn is the common difference. So all these three are also in GP. Now let's talk about properties of GP. If A, B, C are in GP, then B square equals to AC. That is exactly similar to the property which we studied in arithmetic progression. That was B equals to A plus C. Similarly, if A, B, C are in GP, then we can say that B by A would be equals to C by B. And cross multiplying would give me B square equals to AC. That's very simple, right? That was the first one. Now the second one is the common ratio can be positive, negative, or negative but not zero, because if the common ratio is 0, in that case the first term is A, then the second term would be 0, the third term would be 0, fourth term would be 0, and similarly the rest of the terms would be 0. Now if I try to divide this term and this term to find out the common difference, that would give me 0 by 0. That is not possible, right? Because this is not defined, so we cannot define the R value over there. So that is why it cannot be 0. It can be positive or negative, but it cannot be 0. Now the third point is considering numbers in GP. So just like AP, in AP we used to do A minus D, A plus D for 3 terms. Similarly for 4 terms we used to do A minus 3D, A minus D, A plus D, and A plus 3D. Similarly over here, if we have 3 numbers, in most of the cases, not every time, in most of the cases, what we'll do, we'll be doing A by R, A, AR. Similarly for 4, we'll be doing A divided by R cube, A divided by R, AR, and AR cube. This is how we are going to deal with the 4 numbers. This is how we are going to deal with 3 numbers. And similarly, you can go on for 5 numbers as well. Now talking about the fourth property, the product of the terms of a GP equidistant from the beginning and end is constant and is equal to the product of first and last terms. So that is again similar to AP. So let's say we have this GP AR square, AR cube, and let's say we have the remaining numbers as ARn minus 3 and ARn minus 2, ARn minus 1. This is how the GP is being written. Now we have some numbers in between. Now if I take zero place from the, basically if I take the zeroth place from the first, from the beginning, and zeroth place from the end, in that case, and if I multiply both of them, then what I'll be getting? I'll be getting AR dot AR is power n minus 1. That is nothing but A square R is power n. Now, similarly, if I take the first position from the beginning and first position from the end and multiply both of them, I'll get the same, exactly same result, right? So this is the property. Now let's talk about the fifth property. So let's say we have GP called AR, AR square, AR cube, and so on. Right now, if I am multiplying a constant number, let's say K, so this would become KA, this KAR, KAR square, KAR cube. Now what I can do, I can write KA as, let's say, capital A. That would become capital AR, that would become capital A square R, AR square, sorry, and this would become AR cube, right? So again, this forms a GP with the same common ratio, that is R. So that is what I have been told over here. We have to multiply and divide over here. In case of AP, we could have multiplied, divide, we could have added, subtracted. But in case of GP, we can just multiply or divide or raise to power, not addition or subtraction. That won't make sense. Now let's talk about the sixth property. If A1, A2, A3 are in GP, then log A1, log A2, log A3 are in AP, and its converse is also true, where each of A1 is greater than 0, right? So let's talk about the last property. Let's say we have this A, AR, AR square, AR cube. Let's say this is GP. Now if I take log for all these numbers, I'll be getting log A, this would be log AR, this would be log AR square, and this would be log AR cube. Now, if I try to break it down, that I'll be getting log A plus log R. This would become log A plus log R square. That would be 2 log R. Similarly, this one would be log A plus 3 log R, and this one was log A. So let's treat log A as capital A, and let's treat log R as capital D. So this is A plus D, this is A plus 2D, this is A plus 3D, and so on, right? So this becomes an AP. So if I take the log then of a GP, I'll be getting a NAP, and if I do the converse, that is also true. Now let's look at one question. If the sides of a right angle triangle are in GP, then the cosine of the greater acute angle is. So let's say we have this right angle triangle. This is the right angle. Let's say this is A, this is B, and this is C. Now we don't really know if R is going to be greater than 1 or less than 1. So let's use the common sense over here, since this side is bigger. So basically, if R is greater than 1, then these two sides would be smaller one, and this would be the largest one. In that case, this would be AR square. And let's say this is A and this is AR. So this is the least one, this is the second largest one, and this is the largest one, right? Now we have to find out the greater acute angle. Greater acute angle would be, these two are acute angles, angle B or angle C, right? These two are acute angles. Now the greater acute angle would be the one opposite to the bigger side. So bigger side is AR as compared to A. So we have to find this area, this angle, right? Now with the simple Pythagoras theorem, what we'll be doing, A square plus A square R square equals to A square R is power 4. A square gets cancelled out. So we'll be getting R square, sorry, R is power 4 minus R square minus 1 equals to 0. So basically R square would be 1 plus minus under root 1 plus 4 divided by 2. But R square cannot be negative, so minus would be ignored over here. So that would give me 1 plus under root 5 by 2. Now we have to find out the cos theta. So cos theta would be A upon AR square, that would be 1 upon R square. Now R square is 1 plus root 5 by 2. So 1 upon R square would be 2 upon 1 plus root 5. So A would be the answer. Now let us talk about harmonic progressions. So if you know AP, then you definitely know progression, harmonic progressions, because it's as simple as that. So let's say we have A1, A2, A3, A4, and dot dot dot. These four terms or and further terms are in AP. Now, if I do the reciprocal of it, 1 by A1, 1 by A2, 1 by A3, 1 by A4, and so on. Now this sequence is called as harmonic progressions. So that is the definition of harmonic progressions. It's as simple as that. So if you know the properties of arithmetic progressions, if you know the problems, how to solve the problems of AP, then you definitely know how to solve the problems of HP, right? So let's start with one problem. If x equals to sigma this, y equals to sigma this, and z equals to sigma this, where a, b, c are in AP and mod a, mod b, mod c, all three are less than 1, then x, y, z are in these examples, these options. Now let's try to write x. So x is, if I put n equals to 0, that would start with 1. If I put n equals to 1, that would give me a, and then a square, then a cube, till infinity, right? Similarly, that would become 1 upon 1 minus a. Why? Because the first term is 1 over here, and common difference is a, which is modulus of which is less than 1, right? So, and since this is going to infinity, we can use the summation to infinity formula, 1 upon 1 minus a. Now similarly, y would be 1 upon 1 minus b, and z would be 1 upon 1 minus c. Now let's try to understand one thing. It's been given that a, b, c are in AP. Now we have to find out what kind of progression these three terms are in, right? So A, B, C are in AP. Now with the help of properties of AP, if I multiply all three numbers with a negative sign, basically with minus 1, then also they would be in AP, right? Because of the property. So minus A, minus B, and minus C would be in AP. Now if I add 1 to all of them, then also they would be in AP. So 1 minus A, 1 minus B, and 1 minus C, that would be in AP. Now these three terms are in AP. So if I do the reciprocal of each of them, 1 upon 1 minus A, 1 upon 1 minus B, and 1 upon 1 minus C, then these three terms would be in HP, right? So this is how you have to solve this question. So the answer would be D. Now let's look at this question. Let A1, A2 till A10 be in AP and H1, H2 till H10 be in HP. If A1 equals to H1 equals to 2, A10 equals to H10 equals to 3, then we have to find A4 dot H7. Now let's try to find out A4 first. So we have been given A1 equals to 2 and A10 is nothing but A1 plus 9D. Let's say common difference is D. That is 3. We have to find what we have to find. We have to find A1 plus 3D. Now what I'll do, the usual method would be to replace A1 with 2 over here, then find out the value of D, and then use that D over here to find out the value of A4, right? But we can do some kind of adjustment as well in such kind of questions. So what I'll be doing, I'll be multiplying this equation with 2 and adding this to this equation. So that would give me 2A1 equals to 4. And if I add, that would give me 3 times A1 plus 3D equals 7. So that would give me A1 plus 3D equals to 7 by 3. So sometimes doing this saves a little time and a lot of calculations. Now, similarly, we have H1 equals to 2. So basically, let's take the opposite series since H1 equals to 2 and that is in HP. So let's consider the opposite series. That would be, let's say capital A1 equals to 1 by 2. That would be in AP. And similarly, we have A10. That would be A1 plus, let's say capital D, 9D equals to 1 by 3, and we have to find A7, that is A1 plus 6D. We'll do the same calculation over here. What we'll be doing, we'll be multiplying this with 2 and add it to this one. So that would give me 2A1 plus 18D equals to 2 by 3. And if I have to if I'm adding this to the first equation, I'll be getting 3 times A1 plus 6D equals to 1 by 2 plus 2 by 3. That would become 3 plus 4 by 6, that is 7 by 6. So A1 plus 6D equals to 7 by 18. Now this was A7. We have to find H7. H7 would be H7 would be 18 by 7, right? Now we have to multiply A4 dot H7. So 7 by 3 dot 18 by 7. So this would be 6. 6 is the correct answer. Now let us talk about arithmetico-geometric progression. That is the last topic of today's lecture. And as the name suggests, it's a mixture of AP and GP, right? So it looks like something of this sort. A times A plus B times X, A plus 2D times X square, A plus 3D times X cube, and so on. So this is how it looks like. Now, how do we solve it? Let's say we have to find out the summation of all these terms. Then how do we solve it? So we basically try to convert these series, this particular series, into a proper GP only. And how do we do that? I'll multiply the common ratio of the GP with S. So I'll be getting XS equals to, I'll write AX over here. And similarly, I'll write A plus D X square over here. That would be A plus D X square. Similarly, over here, it would be A plus 2D X cube, and so on. So it would go till n plus 1 term over here. So this would give me x times 1 minus x, s times 1 minus x equals to a plus, now this a gets cancelled out, that would become dx. Similarly, over here a plus d cancel out, becomes dx square. Similarly, over here a plus 2d gets cancelled out, becomes dx cube, and till dx is per n. Now this is an additional term and this becomes a standard GP summation, right? So this is how you have to solve arithmetico-geometric progression. Now let's look at this question. If 10 is power 9 plus 2 times 11 is power 1 dot 10 is power 8 till 10 times 11 is power 9 equals to k times 10 is power 9. So we have to find out the value of k. So let's try to write this in a more structured format because we don't have more coefficients over here. So let's write in a more structured format. That would be s equals to 1 dot 11 raised power 0, because it's 11 raised power 1 over here, it's 2 over here, so it must be 11 raised power 0 over here, and dot 10 raised power 9 plus 2 times 11 raised power 1 dot 10 raised power 8 till we'll have the second last term would be 9 times 11 raised power 8 dot 10 raised power 1, and the last term would be 10 times 11 raised power 9 dot 10 raised power 0, right? So this is our entire series. Now we can see that these terms 1, 2, 3 until 10, these are in AP, and these terms are in GP with a common ratio of 11 by 10, right? So I'll multiply this entire series with 11 by 10. So that would be 11 by 10s equals to, now if I multiply 11 by 10 over here, I'll be getting, I'll write this over here, 1 dot 11 is power 1 dot 10 is power 8, and over here I'll be getting 8 times 11 is power 8 dot 10 is power 1 plus 9 times 11 is power 9 dot 10 is power 0, and an additional term 10 dot 11 raised power 10 dot 10 raised power minus 1, right? So this would be our last term. Now if I subtract both of them, what I'll be getting? I'll be getting minus s by 10 equals to 1 dot 11 raised power 0 dot 10 raised power 9 plus this would become 11 raised power 1 dot 10 raised power 8. Similarly, till 11 raised power 8 dot 10 raised power 1 and 11 raised power 9 dot 10 raised power 0 minus, and this 10 would get cancelled out, minus 11 raised power 10, right? Now basically we have minus s by 10 equals to, now this becomes a GP with an additional term of this one. So we have 10 terms in this GP because it's starting from 0, it's ending at 9. So we have 10 terms and this is an additional term. So this would become, the first term is this one, 10 raised power 9 only basically. So a times 1 minus, again r over here is 11 by 10, 11 by 10 raised power 10 divided by 1 minus 11 by 10. So this would be 10 raised power 9 times 1 minus 11 by 10 raised power 10 divided by, this would become minus 1 by 10, and this this would become minus 1 and 10 goes over there. So that would make the power 10 raised power 10, right? So this would become, and we have an additional minus 11 raised power 10 over here, minus 11 raised power 10. This is an addition term. So 10 raised power 10 multiplied, and if I multiply it over here, this 10 raised power 10 gets cancelled out with 10 raised power 10 over here. I'll be getting minus of 11 raised power 10 with a negative sign because minus 1 in the denominator, and this is 11 raised power 10. So this would become minus 10 raised power 10 plus 11 raised power 10 minus 11 raised power 10. This gets cancelled out. So minus s by 10 equals to this. So s equals to 10 times 10 raised power 10. But we have to write in this format, k times 10 raised power 9. So I'll take 110 out from here. That would be 100 into 10 raised power 9. So k would be 100, right? So this is how you have to solve these. These become a little tricky while solving, and you have to be very careful that you are not missing any number, you're not missing any power over here. So it's just calculation intensive and not very conceptual. So today's lecture was till here only, and from tomorrow onwards we'll be starting with AMGM and the properties related to the inequalities of AMGM and that would be the end of progressions. So let's meet tomorrow. Thanks for watching.